Hello and good morning. Welcome to lecture 9. In this lecture, I want to continue the course Artificial Intelligence and the chapter 5 Adversarial Search. But before that, yesterday I asked one of the classmates, your classmate, Saif Ali, to prepare a presentation regarding alpha beta pruning. If Ali, if are you ready?
Yes, I am.
Okay, you can start.
Sure. Let me share my screen. Yeah. Um, yeah. So I am Muhammad Saif Ali. So I'm gonna be presenting this alpha beta pruning algorithm. Let me maximize. Yeah. So alpha beta pruning algorithm is basically a modified version of Minimax algorithm. This is a Minimax algorithm, and why do we need alpha beta algorithm? Well, it's because it's
Sorry,
optimized.
Ali, your sound a little is low. Can you speak loudly, a little high?
My volume is too high.
Oh, okay, okay.
Okay. Okay, it's
Uh,
the highest I am able to.
yes, it's okay. It's okay.
Thank you, sir. So sometimes nodes are never explored. So basically when we are doing alpha beta algorithm, when you're using alpha beta algorithm, we basically get rid of branches that are useless, and that's a good way to optimize an algorithm, the minimax algorithm. So we have two parameters, alpha and beta. Alpha is minimum score that the maximizing player is assured of, basically the highest value. Beta, on the other hand, is maximum value that the minimizing player is assured of. So the lowest value. So if alpha is bigger than or equal to beta, we prune. We get rid of the branch. If alpha is bigger or equal to beta, so I'm gonna be demonstrating because it's a lot easier to talk about this algorithm that way. Let me share my other screen. Um, yeah. So so this is an alpha beta algorithm. So we have 426 -3 20 79 29 52 and 70. We have alpha, which is max, beta, which is min, and if alpha is larger than or equal to beta, we prune. So that's our rules. So the first one, this is max. We have alpha, which is negative infinity, because alpha, we want the highest value, right? So the worst for alpha would be negative infinity. So for beta, it would be infinity, because the worst for beta would be infinity, as that's the worst value. And we're going to transfer that value to the next node on the left hand side, and the alpha is negative infinity, beta is the same infinity. We're going to transfer that to the left hand side here as well. So now we are going to be dealing with the terminal node. Is 4 larger than this alpha, negative negative infinity? Well, yes, because negative infinity is very small. So yeah, we're going to get rid of that one and change it to 4. And then we are gonna be dealing with the next one. Is 2 larger than 4? No, it's not. So we're not gonna be dealing with 2. We're gonna ignore it. And so now we are gonna be dealing with the top one. This one is minimum, min. So is 4 smaller than the beta infinity. So yeah, 4 is smaller than the infinity. So you get rid of this one and change it to 4. And now we are gonna bring that this value down to the next node um here. So alpha is equal to negative infinity, but beta on the other hand is equal to 4. So is this terminal node 6 is 6 larger than the negative infinity? Yes, it is. 6 is larger than negative infinity. And now, like I said before, um if alpha is bigger than or equal to beta, then we prone. So since right now 6 is larger than 4, we prone this value. So we don't deal with this value anymore. This is like gone. And that's a way to optimize your algorithm. And now we are going to be moving on to the next branch. And over here, no, we first have to move this value back up. So is 6 is 6 smaller than 4? No, it's not. And is 4 smaller than 4? Well, it's equal to 4. So yeah, we are gonna stick with our 4. And now we are gonna go back, put this value back up. Is our 4 um is our 4 larger than our negative infinity? Well, yes, because negative infinity is the smallest value. So we're going to turn it into 4, get rid of that negative infinity, and put this value back here. uh, and then bring this down to the next node over here. So is our terminal node 2, is this larger than 4? No, it's not, because 4 is of course bigger, and is 0 larger than 4? Well, it's not, because 4 is of course bigger. So we bring this value back up, since this is the same, since we are gonna be dealing with this one, right? Beta, because beta is min, as you can see here. This one is min as well. The downward triangle is min, the upward triangle is max. And since 4 is smaller than infinity, we are going to be getting rid of infinity and change it to 4. And like I said before, if alpha is equal to beta, or is of alpha larger than beta, we prone. So since over here alpha is equal to beta, we prone this. So basically these are gone. It's another way to optimize, right? So the algorithm is a lot faster. And now we are gonna be bringing this value back up. So over here we're gonna bring it back up. Um, is is our alpha larger than this alpha? Well, it's equal to that, and this one is equal to that as well. So we are gonna be sticking with our 4, and now we are gonna be going back to our right hand side. This one is our last branch. So we're gonna be bringing this over here. Alpha equal to 4, beta is equal to infinity, and bring this over here. So is 5 is is 5 is 5 larger than our alpha? Yes, because 4 is smaller, right? So we get rid of 4 and then turn it into 5, right? And then we bring this and then we deal with the 2. Is 2 like larger than 5? Well, it's not, because of course 2 is smaller. So we stick with our 5 and then bring this up. And is 4 larger than 5? We are gonna be now dealing with min. So is our 5 smaller than our beta? Yes, it's true. Is 5 is smaller than our beta. So we get rid of our beta and then turn it into 5. And then we deal with the next one. And then here is 7. it's kind of confusing, but once you do it 2 or 3 times, it becomes easy. It's not actually hard, it's only confusing. um, so you bring this value over here. Alpha is equal to 4, beta is equal to 5. So is 7 larger than our alpha? Well, yes, 7 is larger than our alpha. So we change this to 7. So since 7 is larger than our 5, like I said before, if alpha is larger than or equal to our beta, we prune. So we get rid of this one. This one is gone. We're not gonna go to this branch. So yeah, let's move this value back up. So 7 and 5. So we're gonna bring it up. This is, as like I said, it's min, and we're gonna be bringing 5 up. Is 5 smaller than our beta? Well, it's equal to our beta, so it's still gonna be 5. We're gonna stick with 5, and then we're gonna be bringing this value up. So this one is max, right? Like I said. So is 5 equal to 4? No, it's bigger than our alpha. So we're gonna get rid of this and turn it into 5. So the answer is 5. It's kind of confusing, but once you try it multiple times, you become used to it. It's not difficult, and 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 yeah, that's all. There's not really much to um this algorithm. It's very
Okay.
easy. Yeah,
Okay,
and
thank you, Muhammad, for your
you're welcome.
presentation and very interesting.
Thank you, sir.
Okay, if any of uh, your student, do you have any question?
Yeah, feel free to ask me if you have any question, even after class.